Good afternoon to all. Uh, Today in this class we are going to discuss about introduction of electrical measurements. First of all, we must know the term measurement. Measurement means it is a comparison of a result of comparison between the unknown quantity and predefined standard. That is the exact definition of the measurement. Actually, it will be adopted as an unit. Okay. So the next important thing is that what are the performance characteristics of an instrument that we must know before starting the analysis of the electrical measurements. So there are two important classifications. One is static and another one is dynamic. So first one is static. So there are number of characteristics accompanied by the static category. And the first one is accuracy. So accuracy, we know that it is a closeness to the true value. That is called as accuracy. Precision means it is a closeness among the readings. That is called as precision. Threshold. Threshold means it is the minimum value of the input to which the instrument will respond or instrument response. That is called as threshold. From this observation, we concluded that an instrument may have high accuracy but less precision, or high precision and less accuracy. Okay. So next one is dead zone. So dead zone, it is the opposite characteristic of the threshold. That is, it is a maximum value of the input to which the instrument does not respond. That is called as dead zone. Similarly, we can have the comparison between the another two terms, stability and drift. So stability means it is the ability of the instrument to make a constant output even though there is some variations in the input. Drift is the undesirable change in the output even though the input variable is kept constant. That is called as drift. And another one, backlash. So backlash is the lost motion or free play in the mechanical elements. So these are the important static characteristics in the performance analysis. And apart from this, we can include another characteristic, that is static error. It is defined as the difference between the two things, that is true value and measured value. Okay. So linearity, these are the other performance characteristics coming under this category, that is static category. The next one is dynamic category. So in this case, we can have four important characteristics. So first one is speed of response. So already we know that the speed of response, it is the rapidity of the instrument with which the instrument responds to changes in the measured variable. That is called as speed of response. An instrument should have the ability to make a response with respect to measured variable. So next one is lag. Lag means already we can use this term frequently, that is lag. That is delay in response, that is called as lag. Delay in the response to the change in measured variable, that is called as lag. So next one is dynamic error. So dynamic error, that is dynamic means changing with the time. So true value minus measured value changing with the time, that is called as dynamic error. Here the no static error is assumed. That is the main design consideration in the category of dynamic error. The last one is fidelity. So fidelity means it indicates the degree of change in the measured variable without considering the dynamic error. In the case of dynamic error, we are not considering or we are not assuming the static error. But in the case of fidelity, we are not considering the dynamic error in response to changes in the measured variable. That is called as fidelity. So fidelity means that it is the exactness in the reproduction of the measured variable. Okay. So the next one, classification of electrical instruments. So we are going to see the various classification of electrical instruments. So there are two important major classifications. So one is absolute instrument and another one is secondary instruments. Absolute instruments means, so both instruments can be used to measure the electrical quantity. Okay, the principle of absolute instruments, it can be used to measure the electrical quantity in terms of physical constant. That is, they give the magnitude of the electrical quantity to be measured in terms of physical constants of the instrument. You can say Arsenal, that is tangent galvanometer, Rayleigh current balance. These are the examples for the absolute instruments. The next one is secondary instruments. So secondary instruments are classified into three important categories: indicating type, recording type and integrating type. So indicating type means it gives the instantaneous value of the electrical quantity to be measured by the pointer on a calibrated scale. So we can say the example for indicating type as ammeter and voltmeter and wattmeter. These are the indicating type instruments. So and another one is recording type. So recording means it must be done over a selected period of time. So what will be done? The recording, that is, it gives a continuous record of variations in the electrical quantity to be measured over the selected period of time. That is called as recording type. For example, we can say strip chart recorder, potentiometric recorder, etc. And next one is integrating type. The excellent example for the integrating type is used in our domestic appliances, that is energy meter. So the integrating type instruments can be used to measure as well as register by a set of dials and pointers. Okay, that is the total quantity of electricity is measured and registered in this type. That is called as integrating type. So the last one is various forces needed for analog indicating type instruments. So what are the essential torques required for the satisfactory operation of the analog indicating type instruments? This is the main portion. So first one is deflecting. So whenever we are giving the input quantity, then the pointer will be deflected immediately. The meaning is, deflecting means it is the torque to deflect the pointer on a calibrated scale based on the electrical quantity passing through the instrument. That is called as deflecting torque. Then what do you mean by controlling torque? The controlling torque is nothing but it controls the movement of the pointer on a particular scale range based on the electrical quantity passing through the instrument. That is called as controlling torque. So again, controlling torque can be divided into two categories: spring control or gravity control. That is, controlling torque is achieved in two ways. So what are the ways? The first one is spring control and another one is gravity control. So in the case of spring control, we are attaching a phosphor bronze spring to the moving system. So whenever the deflection is made, immediately the spring will be twisted in the opposite direction. Okay. So this will cause a opposing force to the motion of the pointer on a calibrated scale. Then only we can get steady position on the pointer. Okay. So at a steady final position, the controlling torque becomes equal to deflecting torque. Okay. So the next one, damping torque. So the damping torque can be used to avoid the vibration of the pointer on a particular scale. Okay, on a particular scale. So the damping, again, it is divided into three categories: air friction damping, fluid friction damping, and eddy current damping. So air friction damping is employed in moving iron instruments. Eddy current damping is employed in moving coil instruments. Eddy current damping is employed whenever we are using permanent magnet, because the strength of the magnetic field should be high enough in order to accommodate the damping type eddy current damping. Okay. So fluid friction damping is rarely used. So these are the basic important concepts of the electrical measurements. Okay, that's all.